Okay, good evening students. Now I am going to explain estimation of nitrogen. This estimation of nitrogen we are to do in the quantitative analysis. Okay, in the quantitative analysis, except nitrogen remaining all elements percentages already in the previous video we discussed. Now we are discussing estimation of nitrogen. Very important one. Okay, if they want to ask question from the quantitative analysis means the main first preference will be nitrogen only, estimation of nitrogen only. Okay, so nitrogen can be estimated by two methods. Nitrogen can be estimated by the two methods. One is Dumas method, and second one is Kjeldhal method. Okay, Kjeldhal method. Okay, so Dumas method or Kjeldhal method. Okay, the Dumas method it is estimated as N2. The Dumas method it is estimated as N2. How it is estimated as N2? The organic compound containing carbon, hydrogen, and nitrogen. Okay, these are passing through CO. If we heat, then what will get? Okay, CO2 will get. Next to H2O will get. N2 also will get. N2 also will get. Okay, so along with these three, Cu also will get. Yeah, okay, so Cu also will get. So this organic compound on heating with CuO will get these products. Okay, so here CO2 is absorbed. CO2 is absorbed in a KOH. Okay, H2O is absorbed in a CaCl2. Okay, the remaining gas will be N2. Okay, where it is present? In this method, it is going to the nitrometer. It is going to the nitro. Okay, so in this way, in the Dumas method, if you heat the organic compound containing carbon, hydrogen, nitrogen with a CO, okay, what will get? CO2, H2O, and N2 will get along with the Cu. Okay, so here how we can calculate the nitrogen percentage. Okay, so by knowing the volume of N2, you can calculate the nitrogen percentage. What is the formula? Nitrogen percentage is equals to N2 multiplied by 28 by, okay, if you know the volume of N2 now, so that's why we will take STP volume 22,400 into volume of N2 at STP. Volume of N2 at STP by weight of organic compound into 100. Okay, so this is the formula. Here volume of N2 at STP means volume of N2 at STP means standard temperature and pressure. Okay, and pressure. Standard temperature how much? 0 degrees or 273 Kelvin. Standard pressure what? 760 mm of Hg. Okay, 760 mm of Hg. At these conditions, if they given volume of N2, then we can substitute directly in this formula. Then we get the nitrogen percentage. Okay, here we will take one problem. Okay, so 0.2 grams of organic compound is subjected to the Dumas method. Okay, and it liberates 74.6 ml of N2 at STP. Okay, then what is the nitrogen percentage? Here they given organic compound weight and volume of N2 at STP directly given. So directly in this formula, if you substitute nitrogen percentage is equals to 28 by 22. Okay, 1400 into 74.6 by organic compound weight 0.2, okay, into 100. Okay, so this is a 28 of 8 times 28 8 times 224, 2 zeros to 2 zeros cancel, so 8 into 0.2. Okay, 8 into 0.2 means 1.6, so 74.6 by 1.6. Okay, how much will get? 46.63. In this way, we can calculate the nitrogen percentage. in Dumas method. Okay. Next one now. Next one. Sometimes sometimes they will not give like this. They will not give directly the volume of N2 at STP. Here we will take one more problem. 0.25 grams of an organic compound, 30 ml of N2, give 30 ml of N2 at 288 K and at a pressure 745 mm of Hg, and at a pressure 745 mm of Hg. Okay. So at these conditions, if they given volume of N2, then how we can calculate? Here volume of N2 not at STP. STP means at these conditions. If they given at a different temperature, then what you have to do? Okay, these values you have to take at initial values. For suppose V1 30 ml and T1 288, and next P1 745. Next here they given aqueous tension. Aqueous tension means pressure due to moisture. Okay, pressure due to moisture. So 80 aqueous tension is equals to 12.7. They given 12.7. Okay. So this is the pressure due to the nitrogen and water. Okay, this value is the pressure due to the nitrogen plus water. So here water pressure given. If you subtract water pressure from this, you will get the nitrogen pressure. You get the only nitrogen pressure, dry nitrogen pressure. So you have to subtract 12.7, then get 723.3. Okay, this much mm of Hg you will get. This is the P1. Next V2. V2 means volume of N2 at STP you have to calculate. Here T2 273 and P2 760. Okay, P2 760. So by using these values, we can use one formula. P1 V1 by T1 is equals to P2 V2 by T2. Okay. So here we want V2. So that's why V2 is equals to P1 V1 by T1 into T2 by P2. Okay, if you substitute all these values, so what P1 how much is 723.3 into V1 how much initially 30 ml. Okay, by T1 how much 288 into T2 273 by 760. Okay, so if you solve this one, 27.20, if you solve this one 27.4 ml will get. Okay, this is the volume of N2 at STP. Okay, this is the volume of N2 at STP. This value you have to substitute in the formula. What is the formula? Nitrogen percentage is equals to 28 by 22,400 into volume of N2 at STP means 27.4 by weight of organic compound. How much is 0.25? 0.25 into 100. Okay, so if you solve this one, 13.6% of nitrogen will get. This is the Dumas method. Okay, I am revising and once again Dumas method. In the Dumas method, nitrogen is estimated in the form of N2. Okay, so in this organic compound containing carbon, hydrogen, nitrogen are acting in CO, gives CO2, H2O and N2. N2 is collected in the nitrometer. Okay, so if it is collected at STP conditions, directly you can substitute in the formula. Otherwise, if they given at different conditions, that volume you have to convert to the STP volume. Later you have to substitute in the formula. Here they given directly STP volume, so directly substituted. But here they given at other conditions 288 K and 745 mm of Hg. So at these conditions they given volume of N2. So this volume we have to convert to the STP volume. How we can convert? These values are initial values and STP values are final values if we suppose. Okay, so at STP values what is the volume of N2? You can calculate by using this equation. Okay, so that volume of N2 at STP is 27.4. Later, if you substitute in the formula, directly will be the nitrogen percentage. This is the Dumas method. Okay. Hello. Okay. So Dumas method completed. Next, Kjeldhal method. Okay, so in this method, nitrogen is estimated as NH3. Okay, very important. In Dumas method, nitrogen estimated as N2. In the Kjeldhal method, nitrogen estimated as NH3. Okay, so how it is estimated as NH3? The organic compound phosphorus, sorry. Okay, the organic compound containing nitrogen. Okay, and heating with H2SO4. Okay, and heating with H2SO4 in the presence of CuSO4 and K2SO4. Okay, it is converting into the nitrogen present in the organic compound is converting into ammonium sulfate. Okay, the nitrogen present in the organic compound is converting into ammonium sulfate. Okay, so this ammonium sulfate on distillation with NaOH. This ammonium sulfate on distillation with NaOH, what will get? Na2SO4 plus NH3 plus H2O will get. Okay, so here we'll get a NH3. So here the nitrogen present in the organic compound is converting into NH3. Okay, so the nitrogen present in the organic compound is converting into NH3. So how much amount of nitrogen is obtained? That you know means you can substitute in the formula, you get the percentage of nitrogen. So nitrogen percentage is equals to 14 by 1000 into normality of acid into volume of acid by weight of organic compound into 100. Okay, here we got base and I written normality of acid and the volume of acid. Here what does it mean? Na means normality of acid neutralizing NH3. Okay, here this ammonia value we don't know, so that's why the ammonia is neutralized by how much amount of acid. So to neutralize one base, same amount of acid is required. So if you know the acid values, you can substitute those values in the place of base, because to neutralize this base, how much amount of base will be there, same amount of or same number of moles of acid is required. So that's why in the place of base values, we can substitute the acid values. Okay, how much amount of acid is neutralizing this one, those values you have to substitute. Okay, next Va means volume of acid neutralizing NH3. Okay, so sometimes they will give the values of acid, they will give directly. Okay, sometimes they will give directly neutralized values. Okay, volume of acid neutralized or normality of acid neutralized, directly they will give. In that case, directly you can substitute in the formula. If you see one example, 0.5 grams of organic compound containing nitrogen is subjected to the Kjeldhal method, and it gave NH3. That NH3 is neutralized by 10 ml and 1 molar H2SO4. Okay, that NH3, it gave NH3. This NH3 is neutralized by 10 ml and 1 molar H2SO4. 10 ml of 1 molar H2SO4. Then what is the nitrogen percentage? Okay, so nitrogen percentage formula this one. Here 10 ml volume of acid neutralized given. Here Na means normality of acid. Here what they given molarity. 1 molar means 1 molar H2SO4 they given. When molarity given means that you have to convert into normality. So normality is equals to molarity into n factor. Okay, normality is equals to molarity into n factor. So here molarity 1 n factor replace the nitrogens in the acid 2. 2 replace the nitrogens are there, so 2. 1 into 2, 2. So the normality will be 2n. Okay, now we can substitute in the formula. Okay, so 14 by 1000. 14 by 1000 into normality of acid 2 into volume of acid 10. Okay, by weight of organic compound 0.5 into 100. 0.5 into 100. Okay, so if you solve this one, here 2 zeros, 2 zeros, 1 more 0, 1 more 0. Okay, this is 0.5 means 1 by 2. 1 by 2 came up means into 2. So 2 2s are 4. Okay, 4 into 14. 14 4s are 56 percentage. So in this way we can calculate the nitrogen percentage when they given directly volume of acid neutralizing the NH3. Okay, directly neutralize the values they given, you can substitute. Okay, directly you can substitute. Sometimes, so if you see the next case, 0.5 grams of organic compound is subjected to the Kjeldhal method and it gave NH3. Okay, to this 100 ml of 100 ml and m by 10 molar, m by 10 1 by 10 molar H2SO4 is added. This much amount is added. Okay, so from this some is neutralized, some amount is neutralized in the NH3. That left acid, that remaining acid or residual acid is neutralized by m by 10 and 154 ml of NaOH. m by 10 154 ml of NaOH. Okay, they given 0.5 grams of organic compound is subjected to the Kjeldhal method and it gave NH3. Okay, that NH3 is absorbed in 100 ml and m by 10 H2SO4. Okay, later residual acid is neutralized by m by 10 and 154 ml of NaOH. Then what is the nitrogen percentage in this method they asked. Okay, so here you have to know one thing, then only you can solve. Suppose this is one juice beaker or juice glass. Okay, so next this is one water glass. Here 100 ml is there. 100 ml is there. Okay, so from this some amount I added to this one. Some amount of water is added to this one. Then how much I added I want to know. How much I added I want to know. Then what I have to do? Okay, so from the 100 ml some amount I added. How much I added I want to know means the remaining, how much left, how much volume of water left here, how much volume of water left. Okay, that I know means that if you subtract from 100 you will get the how much amount of water is added. Okay, but suppose here after adding some amount of water, here 60 ml of water left. 60 ml of water left. Then how much amount of H2O is added? How much amount of H2O is added? 100 minus 60. 100 minus 60 means 40. 40 ml of H2O is added. Okay, this here what I told, that same method you have to apply. For suppose here NH3 is there. To neutralize this NH3, here 100 ml of H2SO4 they given. 100 ml of H2SO4 they given. From this, some amount is neutralizing the NH3 by adding this H2SO4. Okay, after adding some amount only, it is getting neutralized. That remaining volume you have to calculate. Remaining how much volume left. Okay, to calculate that only they given the residual acid is neutralized by 154 ml and m by 10 molar of NaOH. Okay, so by using this one, we can calculate the how much acid left. Okay, like here 60 ml left na, like here how much amount of acid left that you have to calculate. Okay, so how we can calculate by using the neutralization formula NaVa is equals to NbVb. Okay, so here Na, here they given molarity. Okay, this you have to convert into normality. Here replaceable hydrogens 2, so Here m by 10 means 1 by 10. 1 by 10 into m. 1 by 10 means 0.1. 0.1 into here replace nitrogen is 2. So normality is equals to 0.2. Acid normality. Similarly, base normality, here replace OH minus ion is 1 only. So here also m by 10 means 0.1. 0.1. Here NB is equals to 0.1 into 1. 0.1 into 1 means 0.1 only. Okay, 0.1 only. This is the NB. So by using this one, how much amount of acid left that you want to calculate. So volume of acid left is equals to, okay, so NB BB by NA. NB how much? 0.1. BB how much? 154. NA how much? 0.2. So simply it is 1 by 2. So how much it will come? 154 by 2 means 154 by 2 means how much volume will come? 80. Sorry. How much volume will come? 77 ml. Okay. So okay, then volume of acid neutralized. Neutralized is equals to 100 minus 77. How much will get? 23. This is the volume of acid neutralizing. Then what is the formula of nitrogen percentage? 14 into, okay, 14 by 1000 into, okay, normality of acid 0.2, okay, 0.2 into volume of acid 23 by weight of organic compound 0.5 into 100. Then if you solve this one, okay, if you solve this one, 2 zeros, so 2 zeros get cancelled, okay, right, later this is 1.4. If you divide this also, it is 1.4. So 1.4 into 0.8 into 23. If you solve this one, 12.88% of nitrogen will get. In this way, you have to calculate the nitrogen percentage in Kjeldhal method. Okay, when the given volume of acid neutralized directly, you can substitute directly, then you get the nitrogen percentage. When the given excess of acid or residual acid is neutralized by some base, like this given means, first by using the base values, you have to calculate the how much amount of acid is left. Okay, that you have to calculate. That left acid is 77. Initial taken acid is 100 ml. So from the 100 ml, if you subtract 77, you will get 23 ml. This 23 is the volume of acid neutralizing. Okay, then that value, that 23 ml, you have to substitute the formula, then you will get the percentage of nitrogen. This is a Kjeldhal method. Okay, based on the Kjeldhal method, try to practice some more problems. By practicing only, you will get to know. You will understand. Otherwise, it is difficult. Okay.